It's
besides skin.
okay.
Really?
You don't listen to the Beatles?
Oh, Beatles are the best. All right, here we go. You guys ready? So this one you had some trouble with. This is breaking the composite functions into simpler functions. So remember, the hint is whatever's in parentheses can be your g of x. In other words, this x minus 2 right here is your second function, the g of x. So to get the f of x, I would take this right here and just break it apart. Take that out of it. What would you write? 1 over what?
X squared.
Yeah, 1 over x squared. So try number 2. What's your g of x? X minus 4. Very good. So find that g of x first, and then put your finger over it. What are you going to write now?
X cubed plus 1.
Yeah. So 4 over x cubed plus 1. And do you have to use an x in both of them? Yes.
Do we have to show a word for this?
Nope. I'm not showing any work at all. All right, number 3. We're going to make Kayla happy. Kayla, this video is for you. Because I know you're watching. Ah, there, that's much better. All right, so what's in parentheses?
1 minus x.
Yeah, so that's your g of x, 1 minus x. And then cover that up. What are you going to write?
X cubed.
You got it. So that's not so bad, are they?
If you're covering up the whole problem, then where did the X come from?
I'm just covering up, my finger's fat.
Oh.
I'm just covering up what's in the parentheses. So something is being cubed, right? So that something is x.
Oh, okay.
Does that make sense?
Wouldn't it be negative x?
No. Why?
Because you move the 1 and then...
No, I'm removing everything that's inside there, not just the 1, but I'm removing everything in there, right? So wouldn't it be x cubed?
Yeah.
Okay. All right, so then, what's in parentheses? 5x plus 2. Then cover that up. What do you have for f of x?
4 over x squared.
4 over x squared.
You want to do like 2 over x and 2 per square like that? Or is it right?
What do you mean 2 over x?
2 over x is square root of that.
Oh, I see what you're saying. Yeah, don't write that. Although what you have written is the same thing. I just wouldn't, I see why you said that. I wouldn't go that far though. But that's a good thought. All right, so then look at 5. Do you see what's in parentheses is the same? So what's your g of x? X plus 4. And then cover this up. We have an x squared. Cover this up, plus 2x. So now that's super cinchy, correct? All right, now, Matt, this is your favorite part. We're going to find the domain of composite functions. So I really don't have any directions here for you. Yippee skippy. All right. Now it says find the domain of the composite functions when the original functions are restricted. So I just want to briefly talk about the original functions restrictions before we talk about the composite function restrictions. They can be the same or different. How is this function restricted? X cannot equal 0. Very good. How is this restricted?
It's not.
Ah, it was a trick question. There is no restriction on this one, right? So I want you to do fog. So do f of g. So that's what we were just doing, right? Bless you. So I'm going to take my f function and put my g function into it. So that's fully simplified, isn't it? Let's talk about our domain. What's the restriction on this? Hi. What's your restriction on that? What about negative 3? That's right. So x cannot equal negative 3. If you want to put that in interval notation, feel free. Yeah. So do golf now on that one. Same one, but do golf. And then find the domain.
What would you do? When you do compound, do you separate them from the sides?
I will.
And it's not that difficult.
I'll actually show both ways. I'll say there's 3 sides. And I'll say most of it's all that way.
Because I was thinking it's always together, they're always sharing side.
All of these, it's a similar statement. Not so long as it's easy to put. I would say that in the foot around. Please go around your foot around. When on the main one. Some of them will put it there and then the 3 actually. Okay, but yeah.
So sometimes it's separate.
That's really short. They have their own.
And some kids really like the 3 parts and some kids want it separated because they can't handle it.
All right, I'll show both.
Okay. All right, so golf.
I was just saying yay to the golf.
Yay to the golf. So I've got 1 over x there. What's the restriction there? Yeah, so the restriction on the domain is that x cannot equal 0, right? Because that would make that denominator 0.
But then it's still 3, so why can't?
1 over 0 is undefined.
Yeah, but plus 3.
It doesn't matter.
Oh, yeah.
Yeah, if you got something undefined, how do you add 3 to
Yeah.
it? Does that make sense?
Yeah.
Right. All right, so then look at number 7 and do fog and golf for that. So that one's a little bit more complicated, isn't it? So let's. But look what happens. Doesn't your 1 and -1 cancel? Yeah, let me try to pull this up higher. And then you want to make sure you factor that numerator before you look at your restrictions. These are what are left over. What can you factor out of them? X. So you've got x times x plus 2. Set each one of these not equal to 0, right? Because you're going to have 2 restrictions. Dakota, out. There you go. Not out of the room. So for here, my domain has 2 different restrictions. X cannot equal what here? 0. And what here? -2. And we're setting those equal to 0 or not equal to 0 and solving for them, right? Now if you were to do interval notation, you'd have to put the -2 first. So you'd have -∞, comma, -2, parentheses, union, -2 to 0, that would be in parentheses, union, and then 0 in parentheses, comma, positive infinity. So there'd be 3 parts to that interval notation.
Unless you ask for them not to do it.
Right. You're like, if you don't ask it, I'm not doing it. All right, so then we're going to do golf. It's going to happen because how do you have restrictions? You have fractions. Nope. So here's what you're going to write for this one. This is actually, in my opinion, you can leave it simplified that way. I'm not going to make you combine it into 1 fraction. Okay? You're welcome. I could do that, but let's not. All right, so then let's look at the restriction here. What value would x squared have to be for the denominator to be 0? We could factor this if we wanted to. It's the difference of 2 squares, isn't it? The factoring is x plus 1, x minus 1, isn't it? Okay. But you can also think of it this way. If I set this not equal to 0, I'd add 1. And then how do you solve for x squared? You take the square root of both sides, and what do you have to remember to do? A plus minus. So aren't you going to get 2 answers? A positive 1 and a negative 1. If you set this equal to 0, once you get a negative 1. And if you set that equal to 0, once you get a positive 1. So your domain restriction, again, on this one is also 2. X cannot equal positive or negative 1. And so, Kelsey, yes, if I don't ask for the interval, this one will require 3 intervals, right? Yeah. All right, so flip it to the back side. All right. This time we're only going to do 1 on this one. So let's do fog. You do that one all by yourself. I can hear Nelson yelling. She's either really happy or really annoyed. I don't know. Third class. All right, so what did you get for your fog? Did it look like that? Yeah, and I'm going to let you leave it that way. I'm not going to make you put it into one fraction. Aren't you happy? I'm happy with that. That's fine. What's your restrictions? What does this have to be restricted to?
It can't be.
It cannot be negative. So what's the opposite of negative? Or 0. So your domain restrictions, you want to set what's underneath the radical greater than or equal to 0. Notice I took the radical away. We don't need it. I subtracted 3 and then multiplied by 2. And so x must be greater than or equal to negative 6 for your domain restrictions. So this is like the 3rd time we're going over this, right? Is it starting to sink in? Kind of. Good. All right, here's your blast from the past. You know I love these problems. Yes. No. We're just doing fog on that one. So here we go. Blast from the past. Want you to do the difference quotient. So you can either try it on your own and ignore me, or you can listen to me. It's your choice. So f of x plus h. I'm going to take this. Wherever I see an x, I'm putting in x plus h. And there's only one x. So this right here is f of x plus h. Then minus, how does one lose their green pen so quickly? Oh, here it is. Minus f of x. So I've got to put that in parentheses because f of x is 5x plus 1. That's the original function. And then all over h. So this is a more simpler one. Distribute your 5. Distribute the negative. Start canceling out things that can cancel. 5x and negative 5x. Positive 1 and negative 1. That leaves me with 5h over h. Don't the h's cancel? And I was so proud to see not only this is your answer, but what else? What are the restrictions? H cannot equal 0. Oh, thank you. H cannot equal 0. I did not mark you wrong for not saying that, but that is part of your answer. And Sam, you did it on both of them. Excellent. Yes. I know they did it for you, but you're going to put it as part of your answer, so you're used to doing it. All right, and then these last ones are also on your own. Just do fog and goff. You're not plugging in anything into them, and then I'll show you the answers here shortly. So there are your solutions. Do you agree? Okay, good. Oops.
Can you go to